Hey guys, welcome to the PAP section of the graphing linear transformations problem, or notes, sorry. So we just recently learned how to graph our linear transformations, looking at them, seeing what we need to do in order to transform them from the previous. And so I like to compare this to like a before and after picture. You have your before, and then you have the transformation, which will give you your after, which is why we always label our lines. But with the previous section, we're kind of going without the graphing. We're just basically listing what all of these effects would be and what our graph would have to do without having to graph them. So we're going to determine the effect on the graph of the following function below. So we're given the function f of x equals 3x plus 2. So in the scenario that you had to graph this, you would graph this function, that this would be your original function, your before picture. You would graph it and it would be f of x equals 3x plus 2. You'd put that on your graph. Y-intercept is 2, slope is 3 over 1. And then it would ask you to perform all of these different transformations. But here we're not asked to graph, we're just asked to list what would happen if I were to do this transformation. Now we've learned a few transformations already, and here's our little cheat sheet. So when you're adding or subtracting a number, when you're adding or subtracting a number, that's going to indicate whether you go up, down, left, or right. And I'll go back up to kind of remind us. So if we go to look at the up, down, left, and right, remember when we're adding or subtracting, so you clearly see that you're either adding a number or subtracting a number. That's going to tell you that you're going to be translating it either to the left, to the right, or going up or down when you're adding or subtracting a number. So here you see you're subtracting 3, you're adding 2. Now remember, when you're going up or down, that's going to be on the outside. The number is being added or subtracted on the outside. And when you're adding or subtracting a number on the inside of your parentheses, you're going left or right. So just think, if you're inside the parentheses, you're moving side to side. If you're inside, side to side. So that means it can either go to the left or to the right. And with these, you want to remember that they're the opposite. So when we see the x minus 4, we see that the negative 4 is inside the parentheses, so we know it's either side to side. We got to figure out, is it left or right? Now when you're inside, it's always opposite. So if it's minus 4, you want to think left, but it's actually the right 4. With this one, you would actually be going to the left 2. All right, so that's our first transformation that we kind of learned. Okay, we learned that if we're adding or subtracting a number to our function, you're either going up, down, left, or right. The second thing that we learned was when we have a negative sign. A negative sign. Now, negative signs indicate to me that I'm going to have a reflection. So you know that a negative sign is going to give you a reflection. Now, a negative sign is its own thing. You should pretend like it's detached from the number. So if you see a negative, you have to automatically think reflection. Now, you have two types of reflections. You have a reflection over the x-axis and a reflection over the y-axis. The question is, when do you have which? Well, when your negative is in front, it's going to be a reflection over the x-axis, and here's why. So remember, what's the same thing as f of x? The same thing as f of x is y. So technically, you have like negative y, right? So negative y. But you want to think opposite. So if I have negative y, I know that a negative means reflection. So I want to think reflection over the y-axis because it says negative y, but I have to think the opposite. So it's actually a reflection over the x-axis. With this one, where is your negative sign? Well, your negative sign here is in front of the x, so it's a negative. Remember, negatives mean reflection. The negative is on the inside here. And when the negative is in front of the x, you want to think the opposite of x, and so it's going to be a reflection over the y-axis. So these are kind of opposites of each other. So a negative is going to tell me if I have a reflection. Let's go back to here. So if I have a negative sign, that means I have a reflection. The last thing we learned was dilations, but that was basically when we were multiplying. So if I see that I'm multiplying a number, okay, that's going to tell me I'm going to have a slope change, which means I'm going to multiply to the slope, and sometimes the y-intercept. Okay, but not always the y-intercept, just sometimes. You don't always multiply to the y-intercept. So with the examples here, okay, you see that the a is attached to the outside of f of x. Now, what operation is happening between the a and the f of x? It's actually multiplication. So here, there isn't a multiplication sign, but you know they're being multiplied because they're connected, right? Like 3x means 3 times x, we just don't write that multiplication sign in between. So I know this is multiplication because the a is attached right to it, which means it's being multiplied. The question is, would I multiply it to the the slope only, or the slope and the y-intercept? Now, when the number is attached on the outside, you're going to multiply it to everything. So you're going to multiply it to the slope and the y-intercept. So when your number is attached to the outside, you're going to multiply the slope and the y-intercept by whatever that number is. Here, we have the number on the inside next to the x. So this is more concentrated and not on everything. It's just on whatever is next to the x. While the number that's always next to the x is usually your slope. So this, you would only multiply it to the slope when the number is on the inside. When it's on the inside, you're just concentrated on the slope only, and you're going to multiply. And you know it's multiplication because that b and that x are connected to each other, so you're going to do b times whatever your slope is. Oh, give me 1 second. Okay, sorry about that, I got a call. Okay, so let's do some examples here, right? So here I have f of 3x. The 3 is on the inside, and I know this is multiplication, I just don't write that multiplication sign. So the 3 is directly attached and being multiplied. So I know there's multiplication involved. The question is, am I going to multiply it to just the slope or the slope and the y-intercept? Well, you would multiply it to just the slope only, okay, because it's on the inside, so it's more concentrated on the inside. So you're going to multiply the slope by 3. So if your slope was 2, you're going to multiply the 2 by the 3, so your new slope is going to be 6 because that 3 is there. If this number was a 4, then you would multiply your slope by 4, whatever that number may be. All right, now here you have a 2 on the outside. If you have a 2 on the outside, you know they're connected by multiplication, okay? And so if you know it's multiplied by multiplication, then you are going to multiply to everything. And the reason why you would multiply to everything is because it is on the outside, and you would directly put it on the slope and the y-intercept. So you would have it on both things. So it's definitely important where you know where that location is. Okay, so we're going to go ahead and begin with the first example. So again, we're just basically listing all of the transformations that they would possibly want us to graph. So when you're looking at your transformations, you're always going left to right, and you're basically trying to figure out all the different things that are wrong with f of x. So here, not really wrong, but what has changed to f of x. So typically f of x is the normal thing, and so we're trying to look at all the add-ons to it. So I notice that there's a negative sign here. And remember, a negative indicates to me when I have a reflection. So I have to first figure out, is this a reflection over the x-axis or over the y-axis? Well, this negative sign is in the front, so it's kind of like saying negative y. And I know it's the opposite, so this is actually going to be a reflection over the x-axis. Okay, so that negative sign is going to tell me that I have a reflection over the x-axis. There's only one transformation happening here, so then I am done with number 1. Starting with the second problem, I have g of x equals 2 f of x. Here I know that that 2 is connected by the operation of multiplication. So I have to figure out, am I multiplying this to the slope and the y-intercept, or just the slope? Well, because that 2 is on the outside, I am multiplying the slope and the y-intercept by 2. So multiply the slope and the y-intercept by 2. Okay, you're multiplying to both. And I know it's multiplication because they're connected, and that's the operation there. Starting with number 3, I see that I have one thing that's different with f of x, and I notice that there's a 3 attached on the inside. That 3 is on the inside, and it is attached by the operation of multiplication because that 3 is right next to that x, so they're connected by multiplication. So I got to figure out, am I multiplying to the slope or the slope and the y-intercept? Now, because that 3 is right next to the x on the inside, I'm only going to multiply it to the slope. So we're going to multiply the slope by 3. Okay, so that's the only thing that we're going to multiply it to. Starting with number 4, we actually have 2 transformations here. There's actually 2 things that are off with this one. So the first thing I'm going to point out is the negative sign. Remember, what do negatives tell us? Negatives tell us when we have a reflection. Now that negative is on the inside next to the x. So if it's on the inside next to the x, you have to think the opposite, and it's going to be a reflection over the y-axis because it's next to the x on the inside. The next thing I notice is the 2. Now the 2 is going to tell me something else. Now the 2 is being multiplied to the x on the inside, so I have to figure out, am I multiplying it to the slope only or the slope and the y-intercept? Well, because it's on the inside, I'm only going to multiply it to the slope. So we're going to multiply the slope by 2, just the slope only. Starting with number 5, sorry if you hear much background noise, there are people in the hallway because it's passing period. So we have g of x equals f of x plus 5. So the only thing off with f of x here is that I have a plus 5 next to it. Now that plus 5 is on the outside. Now when I have addition or subtraction, I have a translation. I'm either moving up, down, left, or right. Well, because that number is being added to the outside, I'm either going in the up or down direction. And because it's a positive, it's a plus 5, I'm actually going to go up 5 units. And that's the only transformation with number 5. Going to number 6, I have g of x equals f of 0.5x. Now that 0.5 is connected to x by multiplication. So I know I'm multiplying here. But the question is, am I multiplying it to the slope and the y-intercept, or just the slope? Well, because it's on the inside, you're only going to multiply it to the slope. So you're going to multiply the slope by 0.5, or 1/2, whatever you want to prefer, right? It's technically 1/2 as well. Okay. I'm going to go ahead and get rid of those parentheses as well. All right, now we have 7 is g of x equals f of x minus 4. Now here, I only have one transformation happening, and that transformation is on the inside. Now, remember, we read this as x minus 4. So this is a minus 4. So we are subtracting. Anytime you're adding or subtracting, you're going left, right, up, or down. And so because we're on the inside of the parentheses, remember, when you're on the inside, you're moving side to side. So you're either moving to the left or to the right. Now remember, you're going to think opposite when you're thinking left to right. So because you're on the inside and you're moving side to side, when you see a minus 4, you want to think the left, but it's actually you're going to move to the right. Whoops, what did I have right here? This would be to the right 4 units. Okay? And then the last thing with number 8, I have g of x equals f of x plus 2 plus 6. Here I have two transformations happening. I always start to go to the left and move to the right. So the first thing that I notice is the positive 2. Now the positive 2 here is on the inside. When I'm on the inside, I'm moving side to side. So here I would actually go to the left 2 units. The reason why it is the left is because when you're doing left and right, it is always the opposite of what you actually would think it would be. Even though it's positive 2, you're actually going to the left. The next thing I see is this positive 6 that's on the outside. When the number is being added or subtracted on the outside, you're either moving up or down. So because it's on the outside and it's positive, I know that this is going to be up 6 units. Remember, with up and down, it's exactly what you think it is. So if it's positive, it's up. If it's negative, it's down. With number 9, we have g of x equals negative f of 3x minus 4. Here I actually have 3 transformations going on here. And so the first thing that I notice on the left is the negative sign. That's the first thing that I see. Now remember, negative signs indicate to me whether I have a reflection or not. So the question is, do I have a reflection over the x-axis or over the y-axis? Well, the negative is in the front, in front of your f of x. So it's in the front, so it's going to be a reflection over the x-axis. Okay? Now, remember, if it's on the front, it's kind of like saying negative y, but you want to think opposite of y, and you want to think x-axis. A reflection over the y-axis would be if the negative sign was on the inside. The next thing that I see here is the positive 3. Now, that positive 3 is on the inside next to the x, and they're connected by multiplication. So I'm multiplying the 3 to something, but I'm multiplying it only to the slope. I'm only multiplying the slope by 3 because it's on the inside. If it was on the outside, then I would multiply to the slope and the y-intercept. And then the last thing I see on this function is that minus 4 on the end there. Now that's on the outside, so I know that when I'm adding or subtracting on the outside, that I'm moving up or down. And because it's a minus 4, then I'm going to be going down 4 units. Okay, and then lastly, I have number 10, which is g of x equals negative 2 f of x minus 1 plus 3. I actually have 4 transformations going on here. The first thing that I see, again, you always want to think of the negative as separate. So the first thing I see is the negative, not negative 2, just the negative sign. When I have a negative sign, I have reflections. Now because that negative is on the outside, that is going to be a reflection over the x-axis. And again, if you're having trouble with remembering which one's x and which one's y-axis, go back and make sure you look through those notes again and just make sure you're familiar with where that negative sign should be located when you have it over certain axes. All right, the next thing I see is the positive 2. Now that positive 2 is attached to the outside by multiplication because they're right next to each other. So when it's attached right to the outside, you're going to multiply because the operation next to them is multiplication. But because it's on the outside, you're going to multiply to the slope and the y-intercept by 2. Okay, if the 2 is attached to the inside like right here, then you would multiply it to just the slope only. Okay, the next thing I see here is the minus 1 on the inside. Whoops, I have a mistake up here. There we go. A minus 1 on the inside. When you're on the inside of the parentheses, you're moving side to side, and you want to think opposite. So the minus 1 is going to tell me that I'm going to go to the right 1 unit. And then lastly, the last thing I see is this positive 3 on the outside. Now when I see a plus 3 on the outside, I'm either moving up or down, and because it's positive, I would actually go up 3 units. Okay, So that is it for listing all the transformations. So this is basically just like the last section. You need to be able to see what you need to graph, but this part you're not actually graphing anything. You're just writing down what the transformations would be. If you have any questions, please let